Okay, today we're going to talk about Lesson 8.1, dealing with relations and functions. To start, I want you guys to take a few minutes to go through this warm-up exercise as a reminder of how to plot points and to name the coordinates of points on a coordinate plane. So please press pause, take a minute or two to go through this, and then check your answers. Okay, hopefully you stopped, taking a few seconds to go through these questions. Here are your answers right now. Point A, starting at the origin here, is 2 spots to the left and 3 up. So the x-coordinate is your left or right. Your y is your up and down. So because this goes left 2, that's a negative direction, it's a -2. Up 3 would be a y-coordinate of +3. So it's -2, 3. Number 2 doesn't go left or right, goes up 4. So those coordinates are 0 for x and 4 for y. Number 3, point C, goes to the right 4 and up 1. So the x-coordinate is +4, y-coordinate of +1. For D, it goes to the right 3, but it does not go up or down. So that would be an x-coordinate of 3, a y-coordinate of 0. E is to the left 1 and down 2. Left is negative, down is negative. So x is -1, y is -2. And the last point, F, goes to the right 4, so x-coordinate of +4, goes down 4, so a y-coordinate of -4. Hopefully you got all of those correct. You had an assignment also to go through your prerequisite skills for this chapter. Here are the answers for those. Please press pause and take a second to check your answers. Now we're going to start today's lesson 8.1, again, relations and functions. We're going to look at an example to start, to hopefully make the definitions we're going to talk about a little bit easier. Here's a table of values right now, which gives the ages and lengths of 5 different alligators. One alligator is 2 years old and has a length of 32 inches. There's another alligator that's 4 years old with a length of 59 inches. There are 2 different alligators that are 5 years old. One of them is 65 inches long, and the other is 69 inches long. And then there's a 7-year-old alligator that's 96 inches long. Notice in this table, what we've done is we've gone ahead and we've told what each number represents. And then we've assigned a variable, either an x for the age or a y for the length. Okay. We're going to start talking about how these two values are related, the age and the length, how they're related. You can represent this relationship between the age of an alligator and its length by using the ordered pair x, y. Notice ordered pairs have parentheses around the outside of them. And then there's an x value and a y value inside the parentheses separated by a comma. That is the correct way that we write ordered pairs. And they should look like this for this particular table. Notice there's an age and a length that are connected. The 2-year-old alligator is 32 inches long, so that's related or given by the ordered pair 2, 32 inside parentheses. And we continue to do the same thing for each of these 5 different pairs of numbers. 459, 565, 569, and 796. So that's one way that we can represent a relation, okay, between 2 different values. An ordered pair forms a relation. A relation is a pairing of numbers in one set, our x values, which we call the domain, with the numbers in another set, our y values, which we call the range. Each number in the domain is what we would consider to be an input, and each number in the range is what we call an output. Okay? You put a number in, that's your x value. You get a result out, or a value out, that's your y value. For a relation that's represented by ordered pairs, we always have our inputs or our domain or our x values, and our outputs are our y coordinates. So again, x coordinates are our domain, y coordinates are what we call our range. Or inputs are domain, outputs are range. What we're going to do is we're going to list the domain and the range for this relation that we have up there already. These ordered pairs up here, or this table up here. We're going to list the domain and we're going to list the range. A little something to keep in mind over here. When you list a domain or a range, you list each repeated value only once. For example, if you look at this relation, there were 2 points that had the same x value of 5. When we list our domain, we're not going to list the same number twice, so the 5 will only be listed once. And the way we write domain and range is in what's called set notation. And we commonly call domain the set D. We would say D equals, and then we're going to draw these funny looking brackets. And we're going to list each of our values of our domain, or in this case our x values, in order from least to greatest. So the smallest x is 2, the next smallest x is 4, the next smallest x is 5, and even though we have 2 5s in there, we're only going to list it once. And then the last unique x value we have would be 7. So for this particular relation, our domain would be the set of numbers 2, 4, 5, 7. Similarly, we would do the same thing for our range. We would say R equals, draw these funny looking brackets, and list all of the unique values of our range, or all of our y values there. In this case, it would be 32, 59, 65, 69, and cheat a little bit, 96. So this would be the way we list our domain and range, as sets of numbers, listed in order from least to greatest, and only listing any number once, even if it's repeated more than once in that set of numbers. Let's look at another one here, show you how quickly and easily these should be able to be accomplished. We're given a table of values. Again, this one represents a single alligator at different points in its life and how long it is. So this particular alligator, they've checked its length at 1 year, 2 years, 3 years, 4 years, and 5 years. These different years, notice, are labeled as our x values. Those are going to be listed in our domain. So we're going to write D equals, we're going to open up that funny looking bracket, and we'll list those x values, 1, 2, 3, 4, 5. And our range, we're going to do the same thing, R equals, put our bracket, and we're just going to list the different lengths for the values of y. 23, 36, 47, 61, and 73. That's all we have to do when we go to list our domain and our range of a set of numbers. Keep in mind, your domain are always your x values, your range are always your y values. Here are 2 examples for you guys to try now. Please press pause, go ahead and attempt these 2 problems, and then you can unpause it and check your answers as I work them out up here. Okay, our domain for this first one, we're going to write D equals, open up our brackets, and I'm going to list my x values in order. I've got a 0, 2, 3, and 5. Our range for this one we need to be careful of. Again, we want to list them in order. So if I look at these numbers, I've got a 1, a 4, a 7, and another 4. Listing them in order, it's going to be 1, 4, 7. Keep in mind, I'm not going to list 2 4s in my range when I list my range. We only want to list each number 1 time if it shows up more than once. For example, number 2, my domain. I'm going to look at these numbers in order. I've got a -3, a -1, another -1, and a 6. So listing them in order from least to greatest, -3 is the smallest number, then -1, and then that leaves 6. Again, notice I'm not listing -1 twice, I'm only listing it once. And for my range, listing those numbers in order, the smallest one seems to be -1, then 0, then 2, and lastly 4. Hopefully you do well on those. Well, a set of ordered pairs is one way that we can list a relation. But there are other ways that we can represent relations as well. Two other common methods we use is by drawing a graph or by drawing what's called a mapping. And I'm going to show you both of those now. So again, we've seen so far a table of values. We've seen them listed as ordered pairs like you see here. And now we're going to talk about graphing those points and showing what's called a mapping. I'll start with graphing. And this is something that we've done in the past. It's something we opened up this lesson with, being able to give the coordinates of a point on a graph. Keep in mind the first number is our x value. Our second number is our y value. The x value is a measure along the x-axis. It's a measure left or right of the origin in the middle. The second value of an ordered pair is your y value, and it tells you distance up or down from the origin. Okay. So again, x is the first number is left and right, y is the second number is up and down. So for the point -1, 1, we're going to go in the negative direction for x, which would be left, and in the positive direction for y, which is up. So we're going to go left 1 and up 1 and put a point there. For the second point, 2, 0, we're going to go to the right of the origin 2 spots, but we're not going to go up and down because a distance of 0 means you don't move up or down. For the third point, 3, 1, we're going to go to the right 3 and up 1 and place a point. For the next point, 3, 2, we're going to go to the right 3 and up 2 this time instead of 1. And for the last point in this relation, 4, 5, we're going to go to the right 4 and we're going to go up 5. And that's going to leave us a point right there. So since there were 5 ordered pairs, we look at our graph, we have 5 points. If we want to talk about a mapping is a little bit different. A mapping is where we have kind of a display of how our domain and our range are related, how they connect to each other. And we're going to list our domain in the left oval we have up here. And we're going to list those numbers in order, just like when we list a domain. We've got a -1, a 2, a 3, and a 4 for our domain. And in the right-hand oval, we're going to list our range. And our range listed in order, the smallest one is 0. Then we have a 1. Then we've got 2 and a 5. And what we're going to do is we're going to draw a mapping or a connection from one oval to the other. We have a point -1, 1. So I'm going to draw an arrow starting at -1, going to 1 in our range. And I'm going to continue to do that for each one of these points in our relation. So 2, 0, I'm going to draw an arrow from 2 going to 0. 3, 1, I'm going to draw an arrow connecting the 3 to the 1. And then we've got 3, 2. So I'm going to draw an arrow from that 3 again, only instead of going to the 1 this time, it's going to go to the 2. Notice we have 2 different arrows coming off of the number 3. And then the last point is 4 to 5. I'm just going to draw an arrow going straight across from 4 to 5. And that's how we draw a mapping. So again, we've learned 4 different ways that you can represent a relation. You can list it ordered pairs, a set of ordered pairs like we've done here. We have a graph and a mapping, and then again, previously we've seen a table of values, and as a reminder, a table of values might look something like this, where we list the x value with a y value, x value with a y value, and so on. So these are the 4 different ways that you can represent a relation that we've learned so far. Table of values, list of ordered pairs, a graphing, and a mapping. Here's an example for you guys right now. I've listed ordered pairs, 4 ordered pairs, and I want you to draw them as a graph and then do a mapping of those. So press pause now and go ahead and attempt this, and I will do it up here for you to check your answers afterwards. Okay, for a graphing, the point -1, 3, we go left 1 and up 3 and put a point. 3, 4 means we go right 3 and up 4. -3, -2 means we go to the left 3 and down 2. Remember, negatives are to the left for x and down for right. Positives are to the right for x or up and down for y. Our last point up here is 4, -1, so I go right 4 and down 1. Positive and negative. And then if we want to do this as a mapping, again, we're going to draw an oval. We're going to list our x values in order, -3, -1, 3, and 4. And our y values in order would be -2, -1, 3, and 4. And then we're going to draw arrows to connect those. -1 to 3, 3 to 4, -3 to -2, and 4 to -1. The next thing we're going to talk about is functions. A function is a special type of relation. Okay. A relation is any relationship between 2 different values, an x and a y. A function is a special relation. It's a special relation where every input can have exactly 1 output. If I rephrase that using x and y values, it means that for every x value, there is exactly 1 y value. If this is the case, then we say that the output or the y value is a function of the input or x value. Y is a function of x. If for every x value there is only 1 y value. So let's look at an example up here and determine whether we think this relation is a function. This is the first set of numbers we use, talking about the 5 different alligators. Notice we get a point at 232, 459, 565, 569, and 796. To look to see whether this is a function or not, we have to check to see that there are not 2 different points that have the same x value. Well, there's a little bit of a red flag here. If you look at these 2 points, 565 and 569. Because we have 2 different points that have the same x value, we say that this is not a function. It's still a relation, it's just not a function. It's not that special kind of relation we were looking for. Again, to be a function, it means that for every input, or x, there is exactly 1 output, y. This one has an x value that has 2 different inputs, or 2 different outputs, excuse me. Looking at that second example we talked about earlier, notice if we look through, are there any 2 points that have the same x value? No, every one of these points has a distinct or different x value. So for this set of numbers, for this relation down here, we would say yes, that is a function. Pretty easy. Don't let it get too complicated. Just looking to see if you have 2 points that have the same x value. So here's a typical set of questions that you'll see. It says to represent the relation as a graph and as a mapping, and then tell whether the relation is a function. Explain your reasoning. One other question that sometimes gets added into this is also list your domain and your range. For this example, I'm going to quickly go through and plot these points. However, at this point I want you to pause the recording, go ahead and do these questions, and then I will go ahead and do the answers for you. Okay, so 0, 3 means we don't go left or right, we go up 3 units, and I know it's tough to see. 1, 2 goes to the right 1 and up 2. 2, 1 goes to the right 2 and down 1. 4, 4 means we go to the right 4 and up 4. And 5, 4 we go to the right 5 and up 4. Doing the mapping. 0, 1, 2, 4, 5, and negative 1, 2, 3, 4. Connecting those, we go 0, 3, 1, 2, 2, negative 1, 4, 4, and 5, 4. Is this a function? Well, we can look at this and see that every one of these x values, or every point has a different x value, so yes, that is a function. Another way, if you look at the mapping, if you've already done a mapping, you can see that every one of these numbers over here for x only has one arrow coming off of it. If it were not a function, it would mean that one of these numbers over here would have 2 different arrowheads coming off of it, and this one does not. In the second example, negative 2, negative 1, we go left 2 and down 1. 0, 2 means we don't go left or right, we go up 2. 2, 3, we go right 2 and up 3. And negative 2, negative 4 means we go left 2 and down 4. As a mapping, we've got negative 2, 0, and 2 for x. We've got negative 4, negative 1, 2, and 3 for y. When we connect those, negative 2 to negative 1, 0 to 2, 2 to 3, and negative 2 to negative 4. Notice here, we've got 2 arrows coming off of the same x value. That's a quick test to show us that, yep, we've got 2 different points that have the same x value. That is not a function. Another way that you can quickly test to see if something is a function or not is to do what's called a vertical line test. So what I'm going to do right now is I am going to create a vertical line here. Vertical means up and down. To see if something is a function or not, remember you can't have 2 points with the same x value. Well, one way to test that by using a vertical line, if 2 points have the same x value, it means that there are 2. So if I took a point 1, 1 and 1, 2, notice the point 1, 1 and 1, 2 have the same x value. Notice when I look at the graph of them, because they have the same x value, they're stacked one on top of the other. They're on the same vertical plane or vertical line. So a vertical line test is a test where we take a vertical line and we pass it across the entire length of the graph. So I'm line at one point at any given time. It's never touching the line twice. That red line would be a function. If I pass it across this green line, however, so far so good, until I get to a point over here. And if you look over here, right there, this vertical line is touching the graph here, and also down here a couple of times at the same time. This would not be a function. So again, the red line or curve was a function. The green was not a function. A vertical line test is just a quick, easy way to look at a graph and tell whether it's a function or not. Here's your homework for section 8.1. If you have any questions, we'll go over it when I return to class.